We are going to take a test over our exponential functions and sequences that we've been working on. So what we're going to do today is go through our test review. So hopefully you can check your work. If you have any questions, please let me know. You can get your test review signed for 5 bonus points. However, you must have that signed and turned in on the day of the test. So numbers 1 and 2 are going to be using this particular situation. Population of San Francisco was 776,733 in the 2000 United States Census. If the expected growth rate, okay, so that tells you automatically that our B is going to be greater than 1, is 15%, which expression represents the population in X years after 2000. So this is our A, if this is what we're starting with in 2000. So I would strongly suggest you write your own function and then look at your choices. So if you remember, exponential functions are a, b to the x power. So our A is 776,733 times. Now remember, if it's a growth rate, it is higher than 1, and we talked about it would be the 1 plus we change our 15% to a decimal to the x power. We can simplify that to 1.15 to the x, which is going to be answer A. We know it can't be B. This would be a decay because it's less than 1. This would be a growth, remember, 1, 2 of 50%. And then this has a plus, so definitely not the answer. So now we're going to apply that. If the expected growth rate is 15%, what's the best prediction in 2015? Now remember, we're talking about X is years after 2000, so that means our X is going to be 15. And we talked about this a couple of ways in class you could solve this. You could use your calculator. So if we have this equation, 776, 733, parentheses, 1.15, close parentheses. Caret is over here next to the 4. And instead of X, now we have a value for X, so we're going to put 15. Now, this is a scientific notation. If you go up and highlight it and hit enter, it will go ahead and put it in a regular number so we can count backwards. 1, 2, 3, 1, 2, 3. So this is 6,320,324, which is answer D. It takes radioactive substance 30 minutes for 50% of it to decay. So we know that our B is going to be between 0 and 1. If there are 40 milligrams, that's our A of the substance. Which one could we use? So we're going to write f of x is equal, A is 40. And if 50% of it, remember we're doing 1 minus the 50% to the x power, because we're always starting with that 100% or that 1. So we know that is just 0.5. So look at these very carefully. No, that's linear. I'm not sure where the 30 is coming from there. We've got an extra t, which is kind of odd, so it has to be D. Then you need to be able to also write a function from a table, and then we can look at our choices here. Which situation best describes this function? Well, we need to have that function to begin with. So we can do our list and spreadsheets, and we can write that regression. Make sure when you're putting in these numbers that you are doing it very cautiously, especially this, as you can see, I didn't start in the right place, 140,000, because if you get off, then it will cause your answer to be incorrect. We talked about going to cell C1, menu, and I'll write it here for you. Right, so we're in cell C1, menu, 4, 1, and because this is exponential, it will be A. Then we need to put this as X and Y, enter, enter. Okay, here is our regression. And we can see that, in fact, I'm going to move this over here so we can write it. So we have f of x. Our A value is 136,125, parentheses. Our B value 1.0 0.027 to the x power. So when we look at this, remember this is 1 plus, we can go 1, 2, 2.7. So, I'm sorry, my light turned off. 2.7, and this is our percentage. So you can see that it is in fact increasing. So A and B don't make any sense at all. It increases by 2 3/4% every year, or it increases 3,850. Well, this is an increase of 3,850, but we know that because it is exponential, it is not going to increase by the same amount each year. This would be a linear equation. 2 3/4 is 2.75%, which is very similar to what we already have, so we're going to go with C. On the next one, Joanne puts 40 bacteria in her petri dish. So again, this is A, that's what we have. It is doubling, so our B is 2. What is the best function for that? So again, f of x equals 40 times 2 to the x power, which is going to be A. So we need to make sure that we can definitely write that exponential function. He deposits $2,000 in an account. It earns 3% interest compounded annually. So they've already given us this. Remember, this is the same as 1 plus that 0.03, which is our 3%. T is the time in years. What is the value of f of 9? So if T is where the 9 is, that means we need to put the 9 where the T is. So we're going to use our calculator. We're going to say 2,000, 1.03 to the 9. 1.03 to the 9. 2609.55. So not this or this. And then let's look. It says it is the amount after 9 years, after 10 years. We're going to go with C. While traveling through the Amazon, Sandy is bitten by a local spider, poison eliminated from the bloodstream at 10% per hour. So remember, this is 1 minus 10%. Injected 25 milligrams. This is your A. Here's your B. So how much is after 1 hour? So first we need to write our function. 25. 1 minus 10% means that there is still 90% of it in her bloodstream. And it tells us after 1 hour. So we can put that into our calculator. 0.9 to the 1. Anything to the 1 is exactly that amount. Sorry for the glare. So you can see, man, that glare is terrible. Let's see if that helps. It is 22.5.